Hashing passwords before storing them in the database is a great start towards better password security. But it's easy to take it one step further and make things much more secure by using a technique called salting passwords. First, let me explain the weakness in our current hashing scheme. If we only hash our passwords like we did in the last movie, then a hacker could take every word in the dictionary, plus every possible combination of letters, numbers, symbols, etc., and run it through those algorithms, MD5, SHA1, SHA2, etc. The results of that could be stored in a database along with the original input, so that now there's a simple table that can convert from the encrypted string back to the original string. It just records input A yields output B. There's no longer a need to decrypt our encrypted password. One can just look it up in the table. And all the processing that it takes to figure it out has been done in advance, so it's not even a time-intensive process. A hacker can break our tough encryption scheme using just a simple database query. These tables of inputs and encrypted strings are called rainbow tables. They're called that because they include every possibility, like all the colors in a rainbow. So for example, if our password was secret, encrypted using SHA1, we would end up with this very long encrypted string that could not be reverse engineered. But if a hacker took all the words in the dictionary and hashed the word secret in that process, stored the results secret and E5, E9, FA, etc. in a database, then all they have to do is look up and say, hey, what is E5, E9, FA, and so on equal? Oh, it is equal to secret. And just like that, our password can be discovered almost as easily as if it had been written in plain text. How easy are these rainbow tables to get? Well, if you do an online search, you'll find tons of websites offering them to anyone who wants them. But luckily, there's a very simple solution. Just add another string to the password before you encrypt it. That's called salt. It's just like we're sprinkling a little bit of salt on our password, give it a little bit of seasoning before we do our encryption. So now, for example, if we had a string like put salt on the, and then our password, we would come up with a different encrypted string. And knowing the original password would become much harder because we would also need to know what the salt string was, and overall it's a longer string that a rainbow table would have to account for. Now I'm just using put salt on the, but you could use any kind of gibberish that you wanted in there, and that would make it harder to generate rainbow tables for. At that point, rainbow tables have to become almost impossibly large. So that's the basic idea behind salting passwords. It's just adding something extra to the password that you also would need to know to be able to figure out what the password was. There are a couple of variations on it, though, that I want us to look at. One is to use unique salt, that is to use something that's unique to each user, like the username. And then if you combine that in your salt string, now you need to know not just what the salt string is, not just the password, but also the user string as well. So rainbow tables are still impossibly large, but now each user's salt becomes unique to them. There's another variation where we use random salt, where we create a pseudo-random string, either asking Ruby to give us back a random value, or using something like time now, which isn't actually random in the way that we know random, but it's random enough for our purposes because we don't know at what time the user registered. So therefore it adds a bit of randomness to the string that gets generated. Now knowing the password requires not only knowing the salt and the password, but also that random string. So rainbow tables become completely useless because you would have to use every possible time that a user could register, including seconds, in your rainbow tables. And each user's hash is almost random and almost unique. Now it's not totally unique because the same user entering the same password at the exact same second would end up generating the exact same hash. So it's not 100% unique. What we'll be doing is actually using a combination of these two, unique and random salt together. Once we generate that random value, then we need to keep track of it because in the future we need to use that same random value again. We can't get a new random value. We want to know what was the time that this salt was generated. So the only way to do that is to store this salt in the database. And if we're going to store it in the database, well, then we also don't want to store it in plain text. At that point, we want to encrypt it as well. So we're going to hash the salt as well. So here's how we're going to break it down. We're going to make a salt first by using a unique and random bit of salt. And that itself is actually salted because it's got use, with, and to make salt in it. So it makes it very difficult to guess. And then we'll encrypt it. So our salt value would be encrypted, salted, unique, and random. Then we're going to take that salt and we'll use it whenever we encrypt the hashed password. We'll pull it out of the database in order to use it again. And then we'll take that and plug it into another salted string that includes the password and encrypt it. So now that value will also be encrypted, salted, unique, and random. Do you see how that works? Without a lot of effort, it gives us a very high level of password security. So let's try adding it to our application. You'll see how easy it is to do. So we'll open up our models and we'll go into admin user. And right above where I have the hash, I'm going to paste in a new method called makeSalt. So we can just call this method. It's a class method again. So we can just say, hey, admin user.makeSalt. And we'll pass in a string. The string could be anything, but I'm going to be using username. So that's what I've gone ahead and called it. So we're going to use that username with the time now to make salt. Now obviously that salt will change every single time we run it because time now will change. So we're going to be storing that in the database. And then when we do our hashing, instead of just hash, we're going to do hash with salt, and we'll pass in not just the password, but also the salt that we should use. So there we go. And then we'll use it right here. So put salt on the password. So now our password string is salted. And if we're using this value from the database for salt, then it will always be the same. And we can just check to see whether these match up. Let's try it out. So I'll go over to terminal and I'll open up my Rails console. I'm already in the root of my application. And from here, we'll do user equals, and I'll bring in my admin user I had before, find one. That's the admin user I created for me. Now I already have a hashed password in there before that was just simply hashed. We're going to ignore that. What we want to do is user.salt equals, and then we have to make our salt. So tell the admin user model, make salt for me. And what should we use for the salt? Well, we can use anything we want. I'm going to use the username as the unique string. And there it is. That's our salt. So that's now going to be able to be stored in the database. And now whenever we hash the password, including the first time, hashed password, we're going to want to hash it. Admin user dot hash with salt. And then we can put in whatever password we want, secret, and then whatever this salt was that we just had. So we'll take that salt value. Now we have our hashed version. User.save. Okay, so now every time we want to come back, if we want to try and see whether or not this user has the right password, all we have to do is this portion right here. We pull up the user's salt, put in the password that they're attempting, and see whether or not the result matches. Do we still get back this string, C2D4909, etc.? That's all there is to it. And the result looks something like this. Let's just do user. Here's what the user is. Here's the hashed password, and here's the salt, both of which are encrypted and impossible to guess unless you know the full process that we go through in order to generate those. So even if you decide not to use unique user strings and random values, I do encourage you to use at least some level of salt when you're doing your hashing, so that rainbow tables won't be the undoing of your site's security.